Hey there, kids. Today we're going to be learning about line plots. So I chose this PowerPoint slide because I know sometimes when we were doing some of these line plots as our warm-ups in class, most of you were stressed out. It's really not as difficult as it looked. I think you guys are starting to get the gist of it. So let's go ahead and get started. So today's teaching point, we're going to model how to examine the distribution of data in line plots and how to identify clusters of data values. So when I refer to clusters of data values, I'm talking about those number when we have our line plot and we have all those little X's over a specific number or a specific fraction or measurement. That's a cluster. It's how many times that particular measurement has appeared within the data. You will use your understanding of fraction multiplication and division to compare one set of fraction data to another. You're going to also create line plots, so make sure you have your journals in front of you so that you can do this. You are going to inspect data, and you are going to draw conclusions about the data based on your observations. So let's get started. Some of our key vocabulary for this unit: distribution. That means that how are we spreading out, or how are pieces of data clustered within that information. Line plot, a data display that shows the frequencies of the data as marks above a number line. So when we look at our line plot, those are the little X's that we put on top of that number line. And then the scale, the increment by which the numbers along the axis of the graph change. So when we're looking at the axis of the graph, you're looking at your number line and what numbers or measurements are you putting underneath. So for example, if we're talking about eighths, then we will split up our number line into eighths. So it would start with 0 and then 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and then 8/8, which is your one whole. I also want you to keep in mind to remember those equivalent fractions. So for example, 2/8 is the same as 1/4. 4/8 is the same as 1/2. So keep that in mind as we progress. So let's look at our first problem. Tomatoes come in different sizes and types. Mrs. Diaz's class weighed several different tomatoes to the nearest 1/8 pound. The results are shown in the line plot below. We're going to use this line plot to describe how the weights varied. So if you look at this line plot, you can see that it is split up into eighths. So we have 0 to a whole, but that in between, it's split up by eighths. 1/8, 2/8, which is the same as 1/4, 3/8, 4/8, which is the same as 1/2, 5/8, 6/8, which is the same as 3/4, and then 7/8. Our one whole becomes that 8/8, which we know when a numerator and denominator are the same, it equals one whole. By plotting data on a line plot, we are able to get a better picture of what that data looks like and how it is spread out. So if you look at this particular line plot, we can see that for 1/8 of a pound, there were 4 tomatoes. For 1/4 of a pound, there were 3 tomatoes. For 3/8 of a pound, there were 2 tomatoes. For 1/2 of a pound, there were 3 tomatoes. So what we do is we look at this number line and we see that most of the data is clustered between 0 and 1/2 pound. That's where most of the tomatoes are weighing, anywhere between 0 and 1/2 pound. We have 2 outliers, and that's our 5/8 and our 7/8, which they're single by themselves over on the other half of the line plot. Those are outliers. They are not clustered within where most of the tomatoes are weighing. So let's look at this problem. Becky bought a bag of stickers to decorate her scrapbook pages. She sorted the stickers by width. She counted the stickers and found that 18 stickers are 1/4 of an inch wide, 11 stickers are 1/2 inch wide, and 14 stickers were 1/8 of an inch wide. Becky wants to see the distribution of widths so that she can plan how the stickers make a line plot. So what should she do? Think about it. One way to solve a problem is to use the data, but we need to find a way to put that data onto our sheet so that we can better see it. So a way to do that is to create a table. Here's a table with the data that Becky had for her stickers. She has 1/8, and there were 14. She had a 1/4 inch and there were 18 stickers. She had a 1/2 inch and there were 11 stickers. So by creating this table, we are now able to go ahead and create our number line or our line plot. When you do this, make sure that you have your number of stickers from least to greatest. The reason, and when I say that, I mean by the measurement. So for example, I want the smallest measurement on top and the biggest measurement towards the bottom. Why would we do that? Well, we want to make sure that we have it in the proper order so that when we do our line plot, we are plotting them in the right order. So what do I already know? I know that fractions are in eighths, fourths, and halves. So because I know that, my smallest size or my smallest denominator, really, because this is the one that's going to be the smallest pieces, is 8. So I'm going to break my number line into eighths. So the least fraction is 1/8, the greatest fraction is 1/2. My line plot needs to be labeled in eighths. So I already know this. When I label my line plot, I'm going to use 0, 1/8, because I have 1/8 up at the top, 2/8, which is my 1/4, 3/8, 4/8, and then I would continue 5/8, 6/8, 7/8 until I get to 1 whole. So how do we know how many X's we should put above each width? Let's look at our line plot. Here are my widths, right? Here's 1/8. Here is 2/8 or 1/4. Here is 3/8. And here is my 4/8, which is 1/2. So where do I put my line plots? How do I know where I'm supposed to put them? Well, we're going to look back at our table. Here's our table. And I know that on 1/8, I need to put 14 X's because there were 14 stickers. I know for 1/4, I need to put 18 stickers. And for 1/2, I need to put 11 stickers. So here's 1/8, my 14 X's. 1/4, I have 18. And my 1/2, I have 11. So this is what my line plot would look like. If I were to ask you, now that we have this line plot, what is one conclusion that we can make about Becky's stickers? We could say most of Becky's stickers are at least 1/4 inch wide because there are 18 there. We can also say that they are clustered between 1/8 and 1/2 because all of her stickers fall between 1/8 and 1/2. So let's look at another example. Bruce's grandfather gave him a box of old foreign coins. He measured the diameter of each coin. Then he made a table that showed the diameters and how many coins he had of each diameter. How can Bruce show this data in a line plot? So this is an example that you will find on page 251 of your lesson for today. Notice that Bruce's coins have 4 different size diameters. There are 3 coins that have a diameter of 3/8 inches. So if we look at our table, which is the very first thing you should be doing, you are going to create a table with the smallest measurement at the top, which is 3/8, and work your way to the largest measurement, which is 7/8. By doing that, now I can look and say 3/8, there's 3/8 of a diameter, or 3/8 inches, I'm sorry, in diameter, there are 3 coins. For 5/8 inches in diameter, there are 8 coins. For 3/4 inches in diameter, there are 11 coins. And for 7/8 of a diameter, there are 5 coins. So think about how do you want to create your line plot? We need to break it up into increments, which are going to be divided into eighths because 8 is our denominator that is the smallest. So here we go again. Here is our line plot. Now on this line plot, we need to add more to the end of it because we do have up to 7/8. So I want you to pause the video And I want you to go ahead and create your line plot for the data provided. Once you have done that, come back and let's see if your line plot looks like mine. So now that you have completed your line plot, let's see if you did it correctly. The first thing you needed to do was create your number line. Now this is the number line I gave you as an example. I did not fill in the last of it. I'm going to fill it in as we go. The first thing I need to do is to add the number of coins that there were for 3/8. So if you look for 3/8, there were a total of 3 coins. So I put 3 X's. Then I have to look at how many coins were 5/8. There were 8 coins that were 5/8. So I add my number or my measurement to my number line or my line plot, and then I add my 8 X's, which shows that there were 8 coins that had a measurement of 5/8 inches in diameter. Then I do my 6/8, which is 3/4. So when you look at your table, it says 3/4. Remember your equivalent fractions. For 3/4, there were 11 stickers. So I added 11 X's. And then finally, for 7/8, there were 5. So I add my 5 X's. Now, a question you might get related to this data and interpreting it is, what can we conclude based on the data? So one conclusion that I can make is that the majority of the tokens or coins that Bruce's grandfather gave him were larger or greater than 1/2, because the majority of his coins were either 5/8, 3/4, or 7/8 inches in diameter, all of which are greater than 1/2 inch. Only 3 coins were smaller or less than 1/2. So he only had 3 for that. So some of the questions you're going to be working on for today will be related to to line plots and creating line plots based on data. Things that I want you to remember is, first, do not forget to create a table with the data if it is not given to you. Remember, when you create your table, that you are to start with the smallest measurement first and work your way to the largest measurement. Think about what your denominators are and which one is the one that would help you to split your line plot evenly. So for example, for this one, 1/8 would have been the smart way to go. So that's why I did it all in 1/8. If you have questions, feel free to email me or Mr. Yeager, and we are happy to help you. Go ahead and get started. Have a great day.